Hello class, today we're on lesson number 8 in chapter 1, parentheses. Now we've already discussed order of operations, and we understand that when we do order of operations, we're supposed to do our exponents. We do those first, right? And then we're supposed to do any multiplication or division. Okay, let's just put a slash there. Division, and remember we go left to right. Okay, and we're also supposed to do then third step is addition or subtraction. Again, I'm just using a slash there, either or, whichever comes first, and they go from left to right. Okay, so we understand that. Now, we're going to learn about parentheses today because parentheses will help us to change this a little bit, okay? Sometimes we have to group values together for different reasons. So let's read on. Parentheses are the most frequently used symbols in algebra. One way which parentheses are used is to change the usual order of operations. For example, suppose that the sum of 3 and 5 is to be subtracted from 10. Well, because 3 plus 5 is equal to 8 and 10 minus 8 is equal to 2, the answer to this problem is 2. If we tried writing the problem, okay, let's write this problem down. We have 10 minus 3 plus 5. So we're subtracting that 3 plus 5 from 10. Okay, but if we follow order of operations, we know that we're supposed to add and subtract from left to right. And that would give us a different answer because we would then subtract the 3 first, which would give us 7, but then we would have to add the 5, and that would give us 12, which is different from the answer that when we first subtracted or added the 3 and the 5 together, which gave us 8, and we subtracted that from 10, which would have been 2. So this would give us the wrong answer because according to our rules of operations, we do this left to right. Now, in order to show that we want to add 3 and 5 before subtracting the result from 10, we would write it this way. So we would subtract parentheses 3 plus 5 and parentheses. So we would say 10 minus parentheses 3 plus 5 and parentheses. Now we've grouped the 3 and the 5 together. And the parentheses, top of page 47, indicate that the operation inside of them is to be done first. So if we did our math, we would do 10 minus 3 plus 5, which is 8. And that answer would be 2. So we, in a sense, broke the rules, or we changed the rules, the usual order, because we should have done left to right. All we have was addition and subtraction. So we would have done 10 minus 3 plus 5. But because we have parentheses, we're being told you must do what's going on in the parentheses first. So that's very important. In an expression containing parentheses, the parentheses indicate that the operations enclosed within them are to be done before anything else. So I would say over here, the first step, and again, we're not changing the steps because this is sort of a nesting. I'm going to use that term to sort of give you an idea. We first do parentheses, all right? Parentheses. And if we have no parentheses, we simply follow this order. But if we're dealing with parentheses, we work with what's in the parentheses first. In fact, we would actually do all of these operations that are within parentheses in that particular order. So that's what I mean by nesting. Nesting meaning you're going to do all of these within the parentheses, and once you remove the parentheses, well, guess what? You're going to do this the same again. Now, I don't think we have any examples here to show you that nesting word that I'm trying to incorporate here. But what I'm saying is that we follow what's within the parentheses first, and we do the math according to our order of operations: exponents, multiplication, division, left to right, addition and subtraction, left to right. Once we remove those parentheses, then we can go ahead and follow what we had. And that's basically what we did here. If we go back, we did, let's see, we did the parentheses first, so we added 3 plus 5. So we didn't have exponents, okay, nothing there. We didn't have multiplication, nothing there. But we had to do addition and subtraction, so we did addition and subtraction, right? We added these two. Then we went ahead and did addition and subtraction again, which meant we did this twice, okay? We went back and subtracted 8 from 10, and we got the answer of 2. Okay, so now there's also the fraction bar, and let's discuss that. Let's clear up our board. And the fraction bar kind of works like a parentheses because of division, but it's not. It's just basically stating that whatever's above and whatever's below needs to be done in its entirety. In other words, whatever's below is the full denominator. It's what we're dividing by. So let's use the example that they give us here. They give us to show, for example, that the sum of 9 and 3 is to be divided by the difference of 5 and 1. Okay, so the sum of 9 and 3 is to be divided. That means all of it is to be divided by what? Well, it's to be divided by the difference of 5 and 1. We would represent that as 5 minus 1. So we have 9 plus 3, all divided by 5 minus 1. So the fraction bar here means not only to divide, but also to add and subtract before dividing. Why? Because all of this is being divided by all of this. So for us to do this properly, we would have to add 9 plus 3, which gives us 12. And we would have to subtract 1 from 5, which gives us 4. And that gives us 12 over 4, and our answer would be 3. Okay? Because the usual procedure is to divide and multiply before adding and subtraction, the fraction bar acts as the parenthesis symbol. In other words, you have to look at what the parentheses or the fraction bar are telling you before you go ahead and do your order of operations. Okay, because we can't just simply divide and multiply before adding and subtracting, because that's not what they were asking us to do. They were telling us, or they were asking us to add the sum, or rather that the sum of 9 and 3, which means we're adding 9 and 3, is to be divided by the difference of 5 and 1. Okay, so we have some more examples here. We have, for instance, the value of, let's see, example number 1. Let me clear the board. Now these examples are going to show you how to apply. You have to pay close attention to the parentheses, to the division bar, and it does get a little more complex later on, but right now we're just getting accustomed to seeing how to treat, and to seeing the parentheses, how to treat those expressions. We have 7 plus 4 in parentheses. Now the first thing I'm going to teach you is how you would say this. If you were at a board, let me just actually go back and state it. And if I were telling you, I want you to write parentheses 7 plus 4 and parentheses, so that's parentheses 7 plus 4 and parentheses times parentheses 7 minus 4 and parentheses. So you could hear my words and write them exactly how they're written here in the book. And what does that equal? Well, we would have to do the parentheses first. There's multiplication here. Wouldn't we do multiplication first? Well, we can't, first off, because we have to do what's in parentheses. So what do we have? Well, 7 plus 4 is going to be equal to 11. And we're going to multiply that times 7 minus 4, which is 3. Which means our answer is 33. Okay? Let's turn over to page 48. Let's take a look at a couple more examples here. We want to find the value of 4 plus parentheses 11 minus 2 and parentheses squared. Okay, this is getting a little more complicated. So let's fasten your seatbelts. And let's see. We have 4, and again, I'm going to say it so you can see how you would say it. 4 plus parentheses 11 minus 2 n parentheses squared. Now, had I said it differently, let's say I would have just said 4 plus 11 minus 2 squared. If I actually said it that way, this is what I mean. 4 plus 11 minus 2 squared. Okay? In fact, let's go ahead and write that on the other side so we can see how that is not how we would say it. Because if we said it that way, this is how we would write it. So we have 4 plus 11 minus 2 squared. You could see already that this is going to be a lot different. So let's go ahead and do what they said. They said 4 plus parentheses 11 minus 2n parentheses squared. Well, we want to do the exponents first, but we can't because we have parentheses. So we must do what's within the parentheses first. So we would have 4 plus 11 minus 2, which is 9. Okay, now we can put the 9 in parentheses, or we can just say 9, but we're going to square it. Okay, so it'll be 9 squared. Okay, so everything that's inside the parentheses here is being squared. And what's everything? 11 minus 2 is everything. And 11 minus 2 is 9. So we're now squaring the 9. So we have 4 plus 9 squared. Well, what is 9 squared? Well, actually, before we say that, what would be the first step now, or the next step? Well, it is the first step, because now that we've gotten rid of the parentheses, we can go ahead and follow our order of operations, which begins with exponents. 9 squared is 9 times 9, which is 81. So we do that first. Now we can do multiplication or division, which we have none. So we can go on to addition and subtraction, left to right. In this case, we simply have 4 plus 81, which is 85, right? Now, had we done it this way, what would we have gotten? Well, we would have followed the exponents first, which meant we would have had 4 plus 11 minus 2 squared, which is 4, right? So we did our exponents first. Multiplication and division, there's none, so let's go ahead and do the addition, subtraction, left to right. That gives us 15 minus 4, and that answer would have been 11. So is that equal to that? No. So as you can see how we say, okay, this would have been said wrong. Okay, if we would have said 4 plus 11 minus 2 squared, we would have been meaning this, which would have been the answer 11. What we meant was 4 plus parentheses 11 minus 2 n parentheses squared. Okay, let's move on to our last example. I'm going to make a little room over here. And as you can see, it's very important that we follow our order of operations, our parentheses, because we would get the wrong answer. And again, it all depends on what we mean. And it's not to say that this is wrong. Okay, it depends on what we're trying to do. In this case, we were subtracting 2 from 11 and then squaring it. Okay, that was the purpose. Now again, what would have what would have been the reason for us to write this? Well, we can think of the iguanas and the porcupines that we were buying with Mrs. Nagatuk in the previous. But in this case, what we're simply saying is that these two are not equivalent. And so it depends on what you're trying to find and how you would group. So we'll figure out later how we group and why we would group them. But let's use our last example here. We're going to find the value of 10 divided by 6 minus 5. And this is plus 6 times 5 divided by 10. So I think I said that right. 10 divided by 6 minus 1, and we're going to add 6 that we're going to add that to 6 times 5, all divided by 10. So again, the parentheses are not here, but we have a fraction bar. And the fraction bar means that we're supposed to do everything above and below before we do anything else. So let's go ahead and do our math. Now we have just a simple 10 here, so we're going to leave the 10 as is. And we're going to divide that by 6 minus 5. Well, what's 6 minus 5? That's 1. And we're going to go ahead and add this to, well, what's the math up here? 6 times 5 is 30. Okay, 6 times 5 being 30, and we're going to divide this all by 10. As you can see now, it's getting a lot more simple. What's 10 divided by 1? Well, that's just simply 10. And what's 30 divided by 10? Well, it's 3. So our answer here would be 13. When you do your homework, you're going to be challenged to a higher level, and try your best to remember that you do your parentheses first and your fraction, whatever's above and below the fraction bar. Okay.